Okay, let's start. So this is your week 8, 9, right?
Yes, sir.
Okay. Please extend week 9. Okay, it's not in my hand. Okay. So what is the content in week 9?
Sir,
Yeah.
sir, is this the first open session for week 9?
Is this okay, I
Yes, sir.
think yeah, I think yeah. Okay.
And tomorrow is there any session? First
I don't
hands.
know about maybe
Sir,
let me
tomorrow is also a session.
okay, maybe let me check. Okay. Tomorrow is 27. Yeah, you have session solve with us. Yeah, right?
But sir,
Yes.
deadline is tomorrow only.
Yeah.
One session.
Okay. Let's see what we will cover in this session. Okay. So week 9. So what is the content for week 9? Anyone who look week 9?
Random variable.
Yeah, random variable. And then we have types of random variable. Then we have
mass function.
PMF, which will apply in which type. We have two type of random variable. One is what?
Discrete.
Yeah, discrete, and another is
Continuous.
continuous. Now PMF allow for discrete case. Okay, and another thing we have what? PDF. I don't know is this PDF cover in week 9 or not, but this is allow the version of PMF in continuous case. In continuous case, we have no PDF. We have in the place of PMF, we have PDF, probability density function. Okay, and then we have CDF, cumulative distribution function, which is what? Probability of our random variable X take values. This is our cumulative distribution function. Right? Okay. After that, what we have? Expectation and variance of random variable. Okay. Okay. These are the content for week 9. Now, what is the random variable? So anyone who know about random variable. So what happen in if we perform some experiment? So there are we have events. Firstly, we have sample space. Now we know what is the event. Event is subset of our sample space, right? So if we are in discrete case, assume that we have n element in sample space. Okay, cardinality of S is n. Then how many event can be possible? Event are subset of S. So how many subset of S are possible if cardinality of S is n? 2d power n.
Yes.
Okay. Then so if n is infinite, assume that cardinality of S is countable set, means uh, it has like natural number. S is equivalent to natural number. Then we have infinite set in element in S. In that case, how many subset we have? Uncountable subset, which is uncountable. Okay. So we can't define our probabilities in all these events. Okay, all these. It is too time consuming, and it is computation too and we are not interested in that many events. So we define a random variable which define our interest in which type of event we want. Like if we roll a die, okay, if we roll a die, then our outcome are what? 1, 2, 3, 4, 5, 6. Then how many event can be possible? 2 to the power 6. These many event are possible, but I am interested only when my event is outcome is head. I am interested only in this. So what is my random variable in this? Oh, sorry, outcome is even. Sorry, outcome is even. I am interested in. So my event is outcome is even. Okay. So what is my
So events are at 2 power 6.
total number of events? This is my sample space. Then how many subset it have? Possible subsets. How many possible subset we have? In I think in set theory, basic math, you have I think course of math one.
Yes, sir.
There you, I think they definitely give the reason why we have 2 to the power n subsets.
Sir,
Yeah,
so what is mod S?
mod is as is cardinality of S. It's just
Cardinality.
yeah, it's just expression. How many element in S?
Okay.
Okay.
So, what type of set is this below as that has you have written that it's uncountable?
Yeah, 2 to the power infinity.
Yeah, what means
This
it's
is the
it.
power set of all the subset of S. This is the power set of S. This is not, yeah.
Okay,
S is my uncountable countable. Then how many subsets are possible? So
that's to the
subset,
power n. Then why is it's infinity?
it's just notation. Not you can write like this also, but it's just notation. This is uncountable. I'm not proving here that why this is uncountable, but yeah, this is uncountable. Okay. So what is my event here? Event is what? 2, 4, and 6. Now assume that you know probability of what? E. Assume that this is not your fair die. Okay. So assume that this is P. Now you can find what is the probability of what?
Getting an even number.
Yeah. Also you can find what? Probability of E complement. You can also find this 1 minus P, right? If I gave you probability of event happening, outcome of event, outcome is even. If you know probability of E, then you can also find probability of E complement, right? This is not script E. This is single. Okay. Right? Till now, any confusion? See, if you have any doubt, so please ask, because this is tomorrow your, I think, deadline. Okay. So if you have any doubt, you can ask. Okay. So now, if you know E, then you can find probability of E complement. Now, by this, you can also find probability of S, which is all know what is probability of S. Probability of sample space is 1 always. Okay. Now, if I define my random variable is as X is my random variable, which is defined as what? It take value 1 when X is what?
X is even.
Yeah,
Same.
X is even. And 0 when X is even and X less than equal 6. Okay. And X is odd or less than equal 6. Okay. Now, this is my random variable. Now, if I write what is the X inverse? What is the inverse image of 1? This. So, for this is what? This is all X such that f of X is 1. I think you see this definition in set math 1, right? Any confusion till now? So, what is X? X inverse 1. We also denote this by what? X equal to 1. These two are same. Okay. Now, what is
So,
this?
so
Yeah.
but we didn't use this kind of inverse notation in this set. Inverse, like we talked about this notations in sets, but not about the inverse functions. Yeah.
What inverse? See, X
Okay.
is your map. Okay. X is your map. X of X is 1. This is your map. Then I think if you know the F is your map from A to B, then you also heard this term F inverse.
Yeah, that's from B to A.
Not if F is not injective and surjective, then you can't say B to A. Yeah, but you can find that F inverse of terms X or set like 8 dash, which is subset of B, like
Hmm.
this. Yeah. So similarly, this is what? This is your X inverse 1. Okay.
Hmm.
So what is this? This is all the X which are your sample space, because my X is mapping from where to where? S is my mapping from S to 0 1, right? Now what is X inverse 1? X belongs to be X such that X of X is 1, right? So basically what happened? So if you perform your event, then your outcome are like this. S is like what? Your die show 1, your die shows 2, yeah, then this is your 3, and then you have 4, then you have 5, and then you have 6. Now you are mapping these, which are not number, they are expression. Okay. Now you are mapping these numbers to numerical numbers, this expression into numerical number. Like if x, these dots are even, then 1. If x is odd, then it maps to 0. Okay, right? So
So
this is the, yeah.
is it it seems like some thing that we started like in equivalence relation, something that we are dividing out. It's like dividing our sample space into multiple segments.
No, it means, see, in question, now this is my one random variable. Okay,
Hmm.
now my second random variable is my outcome, is my event is what? Outcome is outcome is mm, outcome is prime. Now I am interested in this event. So what is my random variable for this case? Which type of how do I define my random variable? Simple. 1 if my x is prime, 0 if x is not prime. Okay, so it's change your interest, which event you want to find. If you have more than one interest, assume that like in die case, assume that your x is your even, no sorry, x even is your outcome is even, and e2 is what? E2 is outcome. Okay, no, okay, you roll two die, die 1 and die 2. Okay, even is outcome is even in first roll, in first die, sorry, and outcome is odd in second die. Okay, now how to define your random variable? No, no, I have to change, just a second. Equals even odd, yeah. Outcome is sum of outcome is, okay, now uh, sum of outcome is 8. Okay, now this is your e2. So you have two event. Now depending on this, construct your random variable.
Sir,
Yeah,
so can't we use other numbers rather than 1 and 0?
yeah, we can use, in this example I will use different than 0 1. Okay, okay, let's see how we define this. Okay, for e2, my I have even, for assume that for even I have 0 1 type of random variable. For e2 I will define what? I define uh, x1 plus x2. Okay, this is my random variable for x2 e2. So it will give what? Sum of my outcome. Now what is the this x2 inverse 8? This means what? My y such that y1 plus y2. Y is my like this y1 y2. Just say just okay. Yeah. So y is my, so x is x2 my is what? X x1 x2, because my outcome are in pair, equal to x1 plus x2. Okay, now what is the this x2 inverse, sorry, x2 inverse 8? What is the this is what? This is x1 x2 such that x1 plus x2 is 8, or where x1 is lying between 1 to 6 and x2 lies between integer and yeah, and x1 and x2 belongs to be natural number. Okay, now what is the so how many values satisfy this equation?
But
One
so
is, yeah,
after like what's this capital X like and capital X2 and capital X2 inverse? Like
x,
up to the point that it's E2 is outcome in which sum is 6. Till
yeah,
that point.
sum is 6. Yeah,
Yeah.
then I define one random variable which is x2 such that if I put two outcome which I got from my experiment, which are what? X1
Me-
and x2. X1 is die outcome in first die, and x2 is the outcome in second die.
Okay.
Okay, now I define this as x1 plus x2. Okay,
That's some.
because I need because in my experiment they use sum, so
Hmm.
that's why I'm using here sum. You can use any other thing also.
Hmm.
Yeah, so basically you defining your random variable. I'm defining random variable so that you can feel what is random variable. Okay, so
Okay.
depends on your
The
event.
event we are deciding in E1 and E2, no, sir?
Yeah, event will yeah, depend on event. What is your what you want to define your random variable, or in many question they already defined your random variable. Okay.
What's the difference between these two, sir?
Which,
Event and random variable.
so event is what? Events is your just subset of uh,
Something happening or not happening.
yeah, event, firstly event is subset of sample space. Okay,
Yeah, yeah.
now by random, with the help of random variable, you can define many all other things, like see, this is my event, corresponding to this I have random variable such that it takes some value, like in this case, but in this case sum is 8. Okay, this is my event, so here my random variable takes value x1 plus x2. What is the inverse part of this? What is the inverse image of 8? This means when this sum will be 8. Okay, see, when this sum will be 8. So this is my event. Now with the help of this, you can also find what? X8, X7, all these type of random event are also find. Okay, so by the
With the
help
help
of
of
random
event
variable,
only, we defined a random variable, right?
yeah. So event random variable is what? You have some sample space and you map your
Okay.
sample space to some numerical values. Like in rolling a die, your outcome are not integer values, right? You have some
Yeah.
you look and you have some dots.
Hmm.
Yeah. Now I map these dots to your integer values, or depending on my
Okay.
interest, or 1 0, like I can also map to, see, so in sample space I have random variable which maps sample space to 1 to 6, such that if there is one dot, then it maps to 1, it maps to 3, like this. Okay. Or I can also define another random variable. If my dots are even, then it maps to 1. If dots are odd, then it maps to 0. So I'm just defining I defining one map which map your sample space to numerical values
So one
to
event can have
simplify my
any
calculation.
number of random variables.
Yeah, I have any number of variable in one experiment depending on my interest.
Okay.
Okay. So if you see your yeah, in lecture notes, so so you have any example from lecture notes about random variable? How to define your random variable and these things? So now assume that what if I see, okay, let's start with some example. So I am rolling a die with 2 times. I think this example also in your lecture notes. Okay.
Sir,
Yeah.
sorry for this. I had just one doubt from quiz 2.
Okay.
Can I ask?
After this session,
Okay, sir. Okay, sir.
at the end. Okay. Yeah. So we have 2 dies. So everyone know what is the sample space in this case. Okay. Now I am interested in event 1 E1, such that sum is 7, like x1 plus x2. And another event is what? How many outcome will have? Outcome is 3. Smaller outcome. Okay. So E2 is my outcomes are x1 minimum of, no, maximum of x1 and x2 is less than 3. X1 and x2 are my okay, I define it. X1 and x2 are my result in 2 dice. X1 is result in first die, x2 is result in second die. Okay. Now what are my random variable? How can I define my random variable? For event 1 I can define x1 plus x2, my random variable. Assume that this is my y is the random variable, which is this. Okay. So depending on this, if I put y in like this, what is my value of random variable? 2. If I put 1 3, then value of random variable is what? 3.
sir.
Yeah. So in this case, for in this case, my experiment is that the values which I found in which die occur in die 1 and 2 occur, they are less than 3, less than equal to 3. So if you observe this, which kind of random variable you have? It's 0 1. If value is less than 0, less than 3, then its value take 1, otherwise take 0, because I'm interested in only in this event, right? Or you can generate this random variable by y also. How? This will, see, it shows that maximum is less than maximum of x1 plus x2 is less than 3. When this will be happen? okay, by this you can't tell this. Okay, yeah, by this, because see, 2 plus 2 is 4. Okay, so which is greater than 3, but it is your interested event. Okay, so for this I will define what is my random variable. Random variable is what? X, x1, x2, such that maximum of x1, x2, right? So if this maximum less than 3, then okay.
So,
No. Yeah, yeah.
so
Ask.
what if x1 and x2 are equal? Then what about maximum?
Then that x1 you can take maximum for x1 or also x2. No problem with any value. You are saying that 2 and 2, na?
Yeah.
Yeah, then maximum value is 2. Okay, so is this is 0 and 1 if maximum of x1, x2
Then in that case,
is less.
maximum and minimum are the same.
Yeah, maximum and minimum are same. These are the basic. Maximum of x1 comma x2 is less than 3. So what about this value? X of 1 comma 1. This will take 0 or 1.
1, sir.
1. And x 1 2, this is also 1. What about this? X 1 4.
1, sir.
No, y 1. Maximum is 4, which is greater than 3. So it will take what?
So we need to
0.
take the minimum of x1, x2. It's less than 3 or equal to.
What?
So in that case, it's also 1, na?
Which case?
1, comma 4.
In 1 comma 4, what is the maximum of 1 comma 4?
4.
4, which is greater than 3.
Yes, sir.
So which value it will take? This one. Okay.
Yes, sir.
Yeah. So if I'm saying that, yeah, this is your what is the random variable. So if I give you a value that,
So one doubt in 1, 2, we are asking for maximum. In that case, 2 is maximum. Then it's
yeah,
also 0, na?
but 2 is less than 3. If my maximum is less than 3, less than equal to be 3, then it will take 1. See, what is the definition? This is the definition of set. So if maximum of x1 and x2 is less than 3, then it will take 1. Otherwise 0. Okay.
Okay, sir.
Yeah. So now if I give you for y, what is the event corresponding to this? What is, okay, 4. What is the event corresponding to this? This is equivalent to, I already mentioned, this is equivalent to y inverse 4. Okay. Or you can write like this. Okay. Yeah. What is the event corresponding to this? Y1 is
Why
our
such that
sum
y
of,
equals to 4? If y equals to 4, it is 1. Otherwise 0.
no. Our definition is y is sum of outcome x1 plus x2. Okay. This y is sum of outcome.
Oh.
So sum of outcome is 4. What is the what is this event? This value y inverse 4. When will
So
be the
2
sum
and
is
2.
4? So for those, see, if I
For those
take
values,
1 comma
if it
3,
is 1,
then
3,
2,
yeah,
1,
2
3, 2,
comma 2,
2,
yeah,
3, 1.
3 1. Okay. Any other? No. Okay. So this is my event. So if someone gave me a random variable, then I can find events.
Yes.
Okay. Yeah. So this is your
So can't
homework.
we
If
take 0?
but our die zero in die not
Uh,
in die we have only
yeah,
1 2 3 4 5 6 now.
yeah,
Yeah.
these events are from the die outcomes.
Yeah, die game. Yeah. Yeah. Then what we have? So what is the probability of this event? What is the probability of y equal to 4? What is the probability of this?
3 over 36.
Yeah, 3 over 36. Why? Because our event is this. Event contain 3 elements and total number of outcome this. Okay. Okay. Then after that what we have? Now in another case where we define maximum of 1 2. So what is x equal to be 2 in this example? In this case, this is the another random variable which I defined. So what is the value when x will take 2?
That's it's when 1 1 1 2 and 2 1. That's going to be our sample space.
Why? But I define, see, but firstly see what is the definition of x.
What is
X,
x, sir?
x,
X is
x takes
x1,
0.
x2.
X takes 0 when maximum is greater than 3, and
Okay.
x take 1 when maximum is less than 3. Okay.
In this
Okay.
definition, then it's phi, none.
Yeah, it is what? 5. Right.
Yeah.
It is 5. Now, which is the answer? Now, what is this? 1. Which is our interested
When
event?
x
1 comma 1.
max of x1, x2 is greater than
Yeah.
3.
No, max
So
of
1
x1,
4.
max of x1 comma x2 is less than equal to be 3. Okay. See, what is the definition? Max of x1 and x2 less than
Greater
3.
than 3, no? Less than 3.
Oh, less than 3.
1. Okay.
Yeah. Okay. So these are the all event, all outcome which are occur in this event. So these are events for us. Okay. So what is the probability of this happen?
One upon 36.
What?
1 1 1
So
2.
firstly find these all values, all these values.
Yes.
Yeah.
How to find out?
So
1
1 1
1
1 2 1
1
3.
1 2 1.
Then in case of 2 we have 2 1 and 2 2 and 2 3. In case of 3 we have only 3 1 3 2 3 3.
3 3.
Right. So total we
Yes.
have 9. Okay.
9 over 36.
Yeah. I think this is the correct answer. Maybe I. Okay. Then these are the concept of random variable. Now next topic what we have. So I think now you know what is the random variable. Random variable is your one function which take your sample values outcome.
So x is equal to 2. How is 5?
How is 5? In which case?
Sir, x is equal to 2.
X equal to 2 because there is no event which what is the definition of this? This means what? X inverse of 2, which means what? X1 x2
It's not defined.
such that what? See,
It's not defined.
yeah, it for those values x1 and x can take only values 0 and 1. Okay, for 2 there is no argument here. So x never take this value 2. Okay,
And I couldn't understand this last one also.
which one?
Like the one you did after, just after this, was 9 by 36.
These are
Because
the
here
all.
it's 1, 2, 3, 4, 5,
See, these are the event
6, 7,
which are
8.
satisfying this. These are the all outcome which satisfy this condition.
Yes.
So 1 1 satisfy this condition,
Yeah.
1 2 satisfy,
Yeah.
1 3 satisfy, 3 1
Right.
satisfy, 3 2 satisfy, 2 2 satisfy, and like 2 3 also satisfy, and
There's
1.
1, 3, 4,
Okay,
5,
so total
6,
number how many?
7, 8, 9. Yeah, now it's 9.
Okay,
Earlier it was written 8, so I couldn't understand why you were
okay,
written. Okay,
okay,
thank you.
okay. Now what is random variable? Random variable is your a map from where sample space to where some numerical values. It can be integer, it can be real number, it can be what? It can be your finite set 0 1 2 3, like this. Okay, this is your random variable. Okay, corresponding to this. So what is this? I already explained what is this notation. This is what? X
X
for all
inverse
those
of
values,
2.
for that x take value 2. Okay, which is x inverse 2. So similarly, what is this? 3 comma 4. This is what? This is all the values x inverse 3 comma 4, means all the values of x, x1 x2, such that x of x1 x2 belongs to where? 3 comma 4. Okay, like this you have what also have you have you can also find what, if your random variable. Okay, you can also find what? X here, x belongs okay, this x is belongs to 1 and 3. Okay, now assume that your x random variable take only discrete values, means minus n, n minus n minus 1, n plus 1. Okay, like this 0 1 2 dot 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 n. N are x is take only these values. Okay, so what is this in that case? X belongs to be what? 1 2 3, right? Why? Because between 1 and 2 x take no values, x can take only integer values. So for all those values, x inverse of 1 2 is what? 5. You know this open and close bracket, I think, right? Now you can find what is the value of this. Okay, now what we have after this? After this we have types of random variable. Okay, so what are the type of random variable we have? If anyone know. So there are two types of
Discrete and
random variable.
continuous.
Yeah, there are two type of random variable, which is first is
So most
discrete.
of
Yeah,
us like most of us students haven't gone through the videos for now. So
okay,
we are like almost blank for quite a few
just
topics.
second, I will open slides. From
Okay.
there we will discuss. Okay,
Okay.
yeah, no, just week 9. Okay, so we will start from okay. Now you can see. So this is your 8.1 lecture. So in this whole week we saw what is random variable, then types of random variable, discrete and continuous. So if your random variable takes values integers or finite, okay, then your random variable is what? Discrete. If your random variable take countable values like in R, values from R, okay, in that case your random variable is continuous. We will see what is the example of this. Then we have probability mass function. So what is probability mass function? So just yeah. So probability mass function is what? Probability mass function is probability of x. X is your random variable. It will take value. So this is your, assume that f is your PMF, probability mass function. So what is PM f of x? So this is, if this is function, it will take some input and give some output. Okay. So what is this? This is probability of x take value x.
So where are you writing somewhere?
Oh, sorry. Just a second. Now I think. Okay. How to just control?
Visible, sir.
Yeah. Now see. So f is your PMF. Okay. So PMF is your function. Okay. Function from where? From your random variable. Say to where? Random variable in the sense that values which random variable takes, means range space of. Okay. So f is from range of, range is not in the that sense minimum and maximum. Range is like uh,
The
all the
function.
values that x takes. Okay. From this to 0 1 0 1. Why? Because f is a PMF which gives the probability of this event occur. Okay. So probability are always lying in 0 1. That's why it's line 0 1. So this takes some value and gives some value, because this is the function, and function takes some value and gives some output. Okay. So it defined as probability of x will take x. This is the PMF. Okay. We will see later what is the PMF in. Okay. Now what we have? Cumulative distribution function. Okay. So cumulative distribution function is what? This is also a function. Cumulative distribution CDF. So this is also function. So it will take what? Some input and give some what? Output. So what is the, assume that this is my CDF, then it takes value f. What will it defined as f of x such that x take value less than equal x. Okay. Like in die case, if I define my event like sum, x take value x1 plus x2. Okay. Then I am, what is the f of what? 2. F of 2 means probability of x take values less than equal to be 2, right? By definition, which is what? X can take how many values? X can take 0, not 0, 1, 2, 3, 4, up to what? Up to 12, because some maximum value in die 6, and 6 plus 6, 12. Okay. So it can take these values. Now what is this? This is as x take values less than 2. This means x either taking value 1 or x take value 0 or 2. Sorry. This Okay, so I can write this like what? Probability of x belongs to be 1 and 2. Now you know how to open this expression and probability and how to find probability.
So,
Okay.
please repeat this CDF thing a bit more.
Okay.
I
So
didn't
CDF
exactly.
is what? See, PDF gives a particular. So PDF gives a particular probability of event. Probability of x take values x.
So
This is your
CDF.
yeah. I will
Okay.
extend this notion. Okay. So this is your PDF. Now what is CDF? CDF is what? Probability of x take value less than x. Means what? X if x take, assume that this is x is your integer. Assume that. Okay. Now how many possible value x can take? This means x take x belong what? X minus 1 up to, assume that your range started from 0 to n, assume that, then this take value up to this. Okay, what is the probability of this defined as CDF. Okay, either you can define by this, you can define by this. Okay,
It's like same thing that हमने जो
Hmm.
रैंडम वेरिएबल की जो वैल्यूज रखी थी तो हर एक वैल्यू के कोरस्पॉन्डिंग जो प्रोबेबिलिटी है दैट CDF.
So no, so x, assume that in that example what value x can take? X can take 1, 2, 3 up to 12, because sum of two outcome which are 0 to 6 and another is also 0 to 6. What is the sum? Maximum is 12 and not 0 to, and okay, so sum from this is from 2 to, and lowest value is 2. Okay,
Yes, sir.
yeah. Now what is PDF? PDF is probability of x equal to be 1, like x equal to be 2, x equal to be 3, like this. These are different. This is your f1, this is your f2, this is your f3, like this. Okay, now what is CDF? CDF is what? If I'm saying that f of 7, this means what? Probability of value of x is less than 7. Okay, now I can open this is as x take values what? 2,
2 to 7.
3 up to 7.
Okay.
So both are different things. Okay,
Mhm.
yeah. So if assume that we have some graph of CDF, we will see what is the graph of CDF. Firstly we will okay, we will see what is this concept in brief. Okay, so now we have random variable, rolling or die twice, going to, okay, this is the definition. When a probability experiment is performed, often we note that interested in all the detail, but rather than interested in the value of some numerical quantity. So we are not interested in all the event. We are interested in only few of the event. Okay, experiment. In given experiment, there must be, so as I define in here. So in this case, there are how many event can be possible? 2 to the power n. Okay, so I am
Yes.
not interested in all those events. Interested in only few of the event. Okay, for that I define what? My random variables. Okay,
So I get a bit intuition here. Like it's like saying that we are dividing our sample space in some classes,
yeah,
like how we are assigning some X values to it.
yeah, depend, not you can't say these are the classes, but yeah, you just fix your interest,
Hmm.
yeah, and assign probability or on all these things. Okay,
So what I mean by classes is it's like what we studied in maths, that equivalence relationship. That
no, so it is not that kind of classes.
okay.
Yeah, okay, then what we have example is in a rolling or die twice, often we care about only their sum. Okay, so instead of giving probability of observing all the event, we are only observe which sum of the event. Okay, so what it tells, so we only care about their sum most of the time. Okay, so that's why we are defining some random variable which gives value sum of outcome. By that we can define all our interested events. Like in this case, I define my sum, then all possible values can sum can take is 1 2 3 4 no, 2 3 4 5 to 12. So all the interesting events are these. Okay, all the other events are not interested for me at that time if I defining sum. Okay, so like this, this is the, and we are interested. Okay, so these quantities are interested or move. These real valued function defined on a sample space are known as. So what is the random variable? Is the some real valued function defined on sample space. Okay, it's basically a function. Okay, which takes values from sample space and map to real value. Okay, like in this case, rolling or die, two die. What is our sample space? It's kind of tuple. See, 1 2 2 6. These are my sample space. Now I define what is random variable. So in case of random variable takes only real value. So I map this 1 2 to some real value. Similarly, this 2 5 to some real value. So this is my random variable. Okay. Now what is the sample space and rolling or die? This is our sample space. And now I am interested in event what of the outcome. How many outcome will result? The sum is 7. Okay, I already discussed this. And how many outcome will have the smaller of the outcome as 3? Yeah. Okay, this is the different event. So it takes the if you have outcome is like 3 is 5. So smaller term is what? 3 in. Okay, it is like event is like in x1, you have some tuple x1 and x2. Okay, so in this your smaller value, which will be the smaller value? Maybe in, yes, assume that it is. Okay, so what is the smaller value in x1 and x2? How to find that value? Minimum of x1 and x2, right? It will give the smaller value in x1 and x2. And if this is less than 3, then this event, this is interested outcome for me. Okay, this will belong to my event space. Okay, so same is then what we have. So x is what? X denote the sum of outcome of two rows, and y denote
So
lesser
that
of
is
the
going
two
to be the
outcome.
part of the even space, or that's going to the part of how we are denoting this x value corresponding to this.
What?
What I'm saying, it's going to be the event space, like a new event space. या फिर हमने
Hmm.
जैसे कि ई को कोड किया है 0 और 1 सेटिस्फाई कर रहा है तो 1 नहीं तो 0. So that's
Yeah, based on that, see, if my value of x1 of minimum of x1 x2
Mhm.
is less than 3, then
Yeah.
this event, this outcome is interested for me,
Yeah. So
because
like
my event is what?
Mhm.
Because my event is value of smaller value is less than 3.
Okay.
Yeah, so that's why this is interested for me. Okay, that
Mhm.
is also interested for me if greater than 3, because that outcome belongs to where? E complement,
Yeah.
right? Yeah, that is also maybe this is interested for me, maybe this is not interested. It depend on the context. Okay,
So, like if you see now this E and E complement,
yeah,
but they would divide our sample space into
yeah, they
groups,
divide
two
into
groups,
two
two
parts. Yeah,
groups, and both of them are disjoint.
in case of what? In case of 0 1, assume
Yeah.
that in our case where my x is take like value x1 plus x2,
Hmm.
in that case what is my event, I have how many events I have? I have x inverse I
In
define
that case,
x1,
we are having some as
x equal to be 2,
2 to 12.
and like x equal to be no 1 comma 2. This is also belongs to be my event space. This
Okay,
is
but
one I can also define this event now. Like
Mhm.
this, I have so many events. Okay, but all are related to what? All are related to sum,
Mhm.
right?
It's same as saying कि भाई हमारा सम एक है, दो है, या एक है
Yeah,
या दो है, इस
yeah,
तरह
yeah,
से.
yeah.
Okay.
Union of event, intersection of event, like this. Okay,
Okay.
yeah. So like this, we define our random variable too now. So this is my outcome. What is the value of x? What is the value of y? They denote all these things. Okay, just look at this chart and you got some idea what is how to map random variable. So x take what? Sum of two rows, and y take smaller outcome in two rows. So if you see in all these, one is the smallest. Okay, 6 and 1, 1 and 5, 1 and 6. So what is the smaller outcome? 1. In this case, what is the smaller? 1. In this case, what is small? 2 is smaller. In this case, 2 is, in this case 2, in this case 2, like this. So in this case 1. So that's why y takes value 1. In this case, what?
Sir, अगर हम यहाँ पर
Yeah,
जैसे x if we consider just the x values, yeah, like it's going from 2 to like a 12. Okay, so if we are considering only value of x, so our sample space is divided. This 36 values are divided between the values of x, they are mapped to value 2 to value 12 for the x. Yeah.
yeah, yeah,
So in that sense,
yeah,
it's dividing, and each of this
yeah,
uh, division is disjoint.
yeah.
That's why I was saying that
It's see, this is the function. You know what is the property of function?
yeah,
Function is well defined. So if
yeah,
you have two values x1 and x2, both
mhm,
are but both are equal, then you can't have two values for f of x1 and f of x2 are such that they are,
yeah,
see, so
mm,
this property by came by this now, that your sample space is divided into parts.
mm,
Yeah, because if assume that you have some even and assume that okay, like x equal to you 1 and x equal to you 2, these are 2, and
mm,
assume that x belongs to be here, x belongs to be here, then
mm.
your function is not well defined, no?
Yeah,
And
it's
I already defined that, already no, see, x is our function, random
mhm,
variable is function from sample space to,
some
so for
numerical
function
value.
this, for sample function this property is satisfied already. Okay,
Yeah, yeah,
yeah,
mm,
that's why that. Okay,
mm.
now what we have, this is our, I already described this. Now how to find, so x take value 2, how many event can be, means what is the value of x inverse 2? So this is the value, and x is, what is the, when the x value, x take value 3 in this case, so this is what x inverse, x equal to be 3 or x, like x equal to be 2 or x in, you can also write like this, or x inverse 2. Okay, so these all are the those things. Okay, so this is your x inverse 4, and this is your x inverse 5. So these all are the event. Okay, so relative event for x equal to be 2, relative event for x equal to be 3, relative event for x equal to be 4, like this. Okay, any doubt till now? Now I think everyone know what is the random variable, right?
Yes, sir.
Okay, so let's move to next slide, I think. So these all, yeah, now what we have, probability. So what is the probability of this? Everyone know, when x value takes 2. So what is the relative event for x equal to be 2 is this, and what is the probability of this event? This. Okay, so according, similarly, what is the probability of x takes value 2? So what is the relative event for x equal to be 2 3? This. Okay, 1 2 and 2 1. So what is the probability of this event happen? 2 by 36. Okay, similarly, what is the probability of x take value 4? So what is the relative event for x equal to be 4? 1 3 2 2 and 3 1. And what is the probability of this will happen? 3 by 36. Same like this. Okay, I already discussed this, and same for y. You check for y. Okay, now this is your, this is checking for y. Okay, now this is for your, now you toss your coin 3 times. So this is your sample space. Now what, so now you define the random variable. So what is, how many types you define random variable for this experiment? Firstly I define, okay, one year. Okay, so number of head, x denote number of head. So x can take 0 0 1 2 and 3. Okay,
Yes, sir.
and so event, your experiment is you toss coin 3 times. 3 times. Okay, see, head tail, head tail, head tail. Okay, now your sample space, all you know, what is the sample space for this experiment? Head 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 head, head tail, head tail, head, like this. Okay, now I define one random variable is number of head. Now you define one random variable. This is my x1. What
Head
what is
count is
the
1.
what?
When head count is 1.
Okay, when, then it is, now what is the value it will take when head? Acha, okay, you are saying that count of head.
No, no, I am saying when head count is 1, then also I can classify, na?
Okay,
That
okay, yeah, then you can also, but yeah, when head count is 1. Okay, okay. So what kind of random variable is this? How many values it will take?
it will take when head count is 1, it's HTT, then
No, no,
it's
no. Firstly, define which real value is it will take now.
okay.
Yeah.
Let's say it's being 1 and 0 itself.
Okay. One, when head count is 1,
Yeah,
otherwise 0. Okay.
yeah. Hmm.
Okay. Now that's it. Now any other random variable? Okay. For that, this what value it will take? It will take which value? 0, 1, 2,
0,
2,
1,
3.
3.
3. Okay.
Hmm.
Okay. Now you define one another random variable. You can also define number of tails.
Yeah,
Okay. Which value it will take? 0, 1, 2, and 3. Okay.
3.
Yeah. Now another random variable.
Hmm.
Oh, there are so many random
Count,
variables
count of heads or count of tails that we are
which I
getting.
already discussed.
Yeah, number of heads, number of tails, done.
Yeah.
And then it's just head count. Count.
Okay. Can we define random variable which takes not real value? It take values from R2. You know how, what is R2?
Yeah, it's Cartesian plane, the complete
Yeah.
two
Okay.
dimensional Cartesian
Yeah.
plane.
Okay. So can you define random variable which take tuples? Real tuples or real integer tuples in this example,
No,
in this
in this
experiment.
we cannot because it's like values are distinct. It's head or tails only.
You can define now. See,
Oh,
if I define x4 like my sample space, it will take some value from sample space and defined as tuple. Number of head in that, number of head, and second tuple give what? Number of tail. Okay. This is a well-defined function. So we can define random variable in R2 also, but we will not discuss this in this course, but you know, okay, we can define, okay. Now you define some random variable, I define two, you define some, so that we proceed further. Okay, you define in after class. Okay, let's see. So these are the random variable. So what is our interested event? So of that is how many toss will be the head. Okay, so this is my one interesting event, and another interesting event is what? Which toss result in the head first? That is first and second and third toss. Okay, of the three tosses, which toss result the head? Okay, so another event is what? In which position head will first time head occur? Assume that in this case head. At what position head occur? One first position, first time head occur. Okay. What if I write tail head? So my random variable x value, which value it takes? 2. Okay. So okay, now firstly I define the variable. X is random variable such that it takes values number of position of first head. Okay, so how many values it will take? 0, 1, 2, 3. Okay, now this is an interesting question. What is the value of x equal to be 2? How many event in this? What is the relevant event for this? Now answer.
HHT, HTH,
What?
THH.
When it's x2, then it's th. Last can be t or h something, anything. THH.
Okay, these two event are in this. Okay,
Hmm.
any doubt? Any doubt? Okay, let's proceed further now.
In this, why not HHT?
So in HHT, when the first head occur in first position, then what value random variable take for this value? 1. See, x is position of first head. So first head in first position, na?
Yes, sir.
Yeah.
So where is x is equal to 2 defined?
Where
Is
x
2
is 2,
defined?
x equal to be 2. So
Yeah.
x equal to be 2 means your first head occur at second position. So in first position, this means what? In first position you got tail. In second position you got head, and in third position you have two choice, either head or either tail. Okay, like this. Okay. Any
X
doubt?
is equal to 0 means no position.
Yeah, in x equal to be 0, this means what? No head occur. This is tail.
Okay, only one time it will happen.
Okay. Yeah. All outcome are tail. In all three tosses, I got tail. Okay. Now this is the your if x take value your 0, then your relevant event is tail. If x take value 1, then your relevant relevant event is what? Okay, this is another type of random variable. This is okay. Okay, you will see what is the random variable is this. Okay, now this is over. Now I think everyone know what is the random variable. Okay, so we will move to another slide. So now we till now we define what is the random variable. Now we define what is the type of random variable. Okay, for that what we need, firstly there is some example application. A live insurance agent has client, each of whom has life insurance policy that pays 1 lakh up to death. Okay, there is one life is ABO. Okay. Now, what is the random variable for these cases? If you study this, is the event or that the because they already mentioned what is the event one. Okay.
So the
So
amount X is like having the amount of money in units of lakhs. So if we are
okay,
paying one, then it's going to be either zero, either it's going to be one, or either it's going to be two.
okay. Then maybe more than one random variable we can create. Let's see what they create. So X denote the total amount of money that will be paid out this year. Anyway, so what is the so this is our random variable that total money they paid in this year. Okay, any of these client. Okay, now how they define this? So so how many? So they can pay up to what? 1 lakh, and there are two clients. So up to what? 2 lakh they can pay. Okay. So when random variable take values what? Zero when both are the client are live, and if one is died then they pay what? 1 lakh, and if both are died then they pay 2 lakh. Okay. Okay.
Yes, sir.
So yeah, any doubt in this question? So they have two clients
Hmm.
which which who has life insurance policy that pays 1 lakh up to death. Okay, 1 lakh up to death. So if one is died, then how much money they will pay? 1 lakh. Okay.
Yes, sir.
If both are alive, then how much money they pay? Zero.
None. Zero.
And if both are died,
Two
then
lakhs.
2 lakhs. So random variable takes values what? 0, 1, and 2.
Hmm.
Okay, because random variable is what? X denote the total amount of money they will paid out this year for any of these clients. Okay, and what is event A? Event A is that younger one dies in this year. Okay, and beta is older one dies in following year. Okay, and A and B are independent. This is the given assumption is given. Okay. And probability of A happen is 0.5, 0.05, and is 0.1, and the younger client die is 0.05, which is reasonable because younger one is have less probability. Okay, of
So have we assumed these probabilities?
what this is given, not we can't assume. This is given in question. Okay, okay. Now random variable can take value 0, 1, 2. Okay. Now what is the probability of x will take? Now we will see what is the probability that x takes. So what is the relevant event when x is 0?
X is 0 when both are alive.
Yeah, and what is how to define this by a and b?
That's A complement and B complement.
Yeah, okay, this is the relative event. Okay,
Hmm.
everyone got the point? Any doubt in this?
No, sir.
Okay, then what is the when x will take value 1?
That's going to be like at least one of them is alive. No.
This means
No.
either a
Exactly,
happen
exactly,
or
exactly
either
one
b
is.
happen.
Yeah.
Okay,
Hmm.
or either, not or. Okay.
Hmm.
Yeah, so this is your outcome. Okay.
Yes, sir.
Yeah, now what is when this x will be 2?
When it's A and B,
B
both.
both happen.
Yeah.
Okay. Yeah,
Hmm.
which is what? A intersection b.
Hmm.
Right. Yeah.
Yeah.
Okay, now we find probability for these relevant event. Okay, so what is the probability that x takes value 0? This means what? Probability of a complement intersection b complement. Okay.
So what one query here, like we
Yeah,
know that A and B are independent.
we have assumption that a and b are independent.
Yeah. So what type of implication does it have for the A complement, B complement, or it's like A and A, B
So if
com
a and b are independent, then a complement and b complement also independent.
okay.
This is
Uh,
the
so what
property
about
we
its
already discussed.
variation? Like what about its variation? Like A
Yeah,
uh
a and b complement are also independent.
and A complement and B also.
Also, yeah, this is the property we already discussed.
Okay.
Some of the, yeah.
If they are
So
dependent, then how will be the equation, sir? If they are dependent,
if they are dependent, then they give more information about that a intersection b and like this. You can't find by this. Okay.
okay, sir.
For that you need what formula? Formula of probability of a union b equal probability of a plus probability of b plus what?
Minus
Minus.
probability of A intersection B.
Yeah, for that you need this, and you can't find this by product rule because they are not independent. So they must give this information for finding a union b. Okay.
All right.
Yeah. So now what is the probability that x take
Sir,
value 0?
if A complement intersection B complement are independent, then it's possible A and B are also independent.
Yeah, all are possible. If any of the a and b or a and a complement or a and b complement or b or a complement, any of the event is independent, then all are the independent. We already discussed this property. See, we proved this. But if a and b are independent, then a and b complement are independent. We already proved this. Okay. Okay, if a and b complement are independent, then I can say from this a complement and b complement is independent. If this is independent, then because why? Fix this is as b dash. Then if b and b dash are independent, then a complement and b dash is independent. Now fix your a as a dash. Now you can say what? A complement and b complement is independent, and b complement is what? B complement. B, sorry, b. Okay. So you can prove this, and I already proved this in some of the discussions. So just use this formula and you can find probability of x equal to be 0. Okay. Now what is the probability of x will take value 1? Now see, a intersection b complement and a complement intersection b both are disjoint. So what is the probability of these intersection? Is 0. Okay. This is the point here. That is why we use some formula, but we know there is no negative expression. Okay, because that is 0. See, what is, so this is our, if I Venn diagram, so this is our A intersection B complement. This is our A, this part, only this part, okay, not that, and this part. A complement intersection B. These both, these two are independent, so disjoint, right? There
Yes,
is
sir.
no common. Yeah.
Yeah.
So what is the probability of this? Probability of A intersection B complement union A complement intersection B is what?
Some of the
Probability of
That
A intersection B complement plus probability of A complement intersection B minus what? Intersection term. But that intersection is 5. Okay.
yeah.
Now that which is 0. That's why we use this formula we use here. And now you can find what is the probability that X will take value 1. Okay.
Hmm.
Similarly, you can find X will take value 2. What is the probability? Like this, you can find. So what is the discrete random variable? Discrete random variable is what? That random variable takes values at most countable numbers. Countable numbers are, what is the countable numbers? What are the countable numbers? Either your set is finite or what? Countable. Countable means, assume that you have set, then you can find a map. If you, I think you discussed this in math 1. Okay. So natural number set is your countable set. So all, if assume that you have set S have element. If you write your element of X like this, X1, X2, dot 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 Xn, like this, so that you can map this to 1, 2, 3. Then S is your countable set. Okay. Countably infinite set. Countably infinite. Okay. So this is your what is countable and uncountable. So if your random variable takes values countable numbers, then your random variable is discrete, otherwise continuous. Okay. Any doubt? Like,
Means if it's like infinite set, the sample space, then its random variable is going to be continuous random
no, no,
variable.
no, no, no. See, natural number, how many element in natural number?
It's infinite,
Infinite,
right? Yeah.
but it is not uncountable. Okay.
Oh, yeah. Yeah,
Natural number set is countable, countably infinite set.
yeah, countable.
Yeah.
Means
Yeah.
any set that this countable
Have
sets,
discrete
it
number.
should.
Discrete number means you can count those numbers.
Okay.
Okay.
Mm,
And
mm,
if you take uncountable set like your R, real line, so
mm.
you can't count your numbers.
Yeah, we cannot.
Yeah. So also, if you take any interval 0 to 1, can
Mm.
you count all numbers between 0 1?
No,
We
if
also even know how many numbers between two rational numbers. Okay.
mm, yeah.
So these are the facts. Okay.
Mm.
So what is countable and uncountable, and what is discrete random variable and countable random variable? This is the definition. So only finite random numbers and countable infinite number different. So different values. So the any random variable that can takes only finite numbers or countable infinite numbers of different values is the discrete random variable. Otherwise, uncountable. Okay. Otherwise, continuous. Okay. Also, there exists a random number, random variable whose set of possible yeah. So there is random variable whose. So can you give some example in which random variable takes values from countable uncountable numbers like real line?
Mm. Uncountable
Yeah, like
natural
height of
number.
person. If you are you sample some person, you have some collection of student, then you are finding that height is you are you make some statement like in India maximum height is 6. Okay, so this is your what. For that you define one random variable which denote height, and height is like 0. So height not in numbers, height can be 5.7, 5.8 like this, 5.77778 like this. Okay, so this kind of random variable is what, continuous. Okay, or you can find what, any other random variable, continuous random variable.
Wait.
Stock price, daily stock price. Okay, right? Stock price is countable, is continuous random variable or not?
It is continuous. It
Yeah,
can have
because it can, yeah,
values.
yeah. Okay, so these are the summary. Now we will move to next slide. If any doubt in this slide, you can ask.
In a sense, countable is when we are dealing with fractional values.
Yeah, yeah. Okay, then now we have what we have. Now we know what is the, how many types of random variable we have. Now we have what, probability mass function. So what is the probability mass function?
So, could you give an example of one more example of when this x is mapped, x maps to this continuous numerical variable?
Stock price, daily stock price, or you can say mm, yeah, weight of person. Weight is also you can get weight in fraction also, no?
Means in the context like we perform these experiments that rolling a dice, tossing a coin, and
So
so on.
in
We were
rolling a die,
mapping.
there are how many outcome we have?
It's
If
finite, finite.
so, see what is the random variable? Random variable map your sample space to real numbers.
Yeah.
Okay. Okay. Now you are saying that my random variable takes uncountable values. This means what? In your sample space, there are uncountable values.
Uncountable. Yeah.
So I can't define for
Hmm.
die. Okay, now I can define for what? For I have I am rolling die. No, I am tossing coin infinitely. So there is one machine which toss coin forever. Okay.
Hmm.
So what is my uh, outcome? Head, tail, head, tail, like this, infinite time.
Yeah.
So, and you know what is the, this is your what, uncountable. Okay.
Yeah.
Now how many element in sample space?
Infinity, we don't know. It's going on and on and on.
Okay. Now what I will define from this. Okay, assume that I am rolling die infinite, because in case I have. Okay, so yeah, yeah, I have die infinitely, so I get 1 2 1 3 4 5 like this, dot dot dot. So this is the infinite. Now I sum these all values. Okay, and divided by what, 6. Okay, what value will be come?
Each value, if I perform with the each value, then it's going to be 1 to 5.
Assume that this is not infinite trial. I am rolling die. Assume that how many times I have to
The summation of
assume
x.
that assume
Okay.
that 100. Okay.
Hmm.
Now
Hmm.
what is the sum? Sum is finite. Okay.
Yeah,
In
it's
this
fine.
case, if I divide, then what value I get?
I will get some finite value. It's some remainder. So
Yeah,
remainder
it's
is
some
quite
fraction,
possible.
in fraction.
Yeah,
Okay,
fraction.
and I don't know how many values I will get, because
Yeah.
in case of 1 1 1 1 1 1, I will get assume that how many times I will get 100 times. In that
Yeah.
case, I will get different. In case of 1 2 1 2 like this. So like this, okay.
Okay.
Now assume that this is also we can define some. Okay, assume that yeah.
सर इससे ऐसा भी लग रहा है जैसे कि एक फिक्स नंबर ऑफ हमारी एक्स एक्स वैल्यू है, वो एक फिक्स्ड लिमिटेड नंबर ऑफ वैल्यूज नहीं ले रहा है
Yeah, yeah.
वो। हम्म।
So your outcome space is also uncountable in that case. Okay?
Yeah.
Yeah. Now this is the example I think. Yeah. For continuous I think. Yeah. There are the four floors in the apartment complex. Each floor has three apartments, one room, two and three bathroom. One data is okay. Data is given. Apartment 1 2 3. There are how many apartment? 12 apartment. Number of floors. Okay. First, second. Yeah. Number of bathroom. Yeah, apartment size is also given. And distance of apartment from the lift also given. Okay. So random experiment is selecting the apartment in the apartment complex of 12 apartment. S is what? S is our sample space 1 to 12. Okay. Now our random variable is what? Let the random variable is the number of bathroom. What are the possible value it can take? So how many possible bathroom we have? 1 2 and 3. See, if in question it mentioned that there are three type of apartment. One bathroom. Oh, one bedroom. Sorry. Second, two bedroom. What is the question? Yeah, the question is yeah. How many? Yeah, how many bedroom in the apartment? There are three possible. One, two, three. Okay. Second question is let the random variable is the floor number of the apartment. What are the possible value it might observe? So how many floor are there? 12. Oh, sorry. How many floors are there? Just second. What is the question? In question, how many floor it mentioned? Okay. So there are four floors. Okay, in the apartment complex. Okay. Yeah. So it will the second random variable can take values like 1 2 3 and 4. Okay. Now similarly third random variable is what? Size of apartment. So which value it will take? It will take discrete continuous values in like interval. So like in this, if you see your data, so these are the so your data from where to where? 900 to 1700 something. Okay. So these many values your apartment size can be take. Okay. So our third random variable is what? Continuous random variable. Okay. Any doubt in this? Similarly, let the yes similar argument for what? Distance of apartment from lift, and this will take these many values. So this is just what is continuous and discrete. Now we will discuss what is PMF. Okay. Yeah. Now what is PMF? Now learning define a random variable. We know what is discrete. Okay. What is continuous?
Sir, that is done now.
That is done. Just yeah, that is done. Yeah. This is for now we will discuss probability mass function and what is graph of probability mass function and like this. Okay. So I already mentioned what is the probability mass function. So see a random variable that can take on at most countable number of the possible ways is called yeah we know what is the discrete random variable. Okay. A random variable which take discrete numbers, at most countable numbers. Okay, so a random variable that can take at most a countable numbers. So I already did. So this means what? So if x is discrete, if x is discrete, then this means x take countable numbers, and I can write countable numbers like x1 x2, means I can write countable numbers. Okay, till xn. Okay, now what is other thing? Now what is the PDF? Probability mass function is probability of random variable x take xi is p of xi. See, p is my function, p of x is my function of x defined by p of x equal to probability of x take value x xi. Okay, which I already mentioned. Now see, if x take value x1 x2 x3 x3 xn, then what is the this is my what, this is defined probability mass function. Okay, now let take for some example. Okay. So there will be some properties of probability mass function. What are the probability property? First, it is always greater than 1. Why? Because this is the probability. So probability can take value between 0 and 1. Okay, so now, okay, now assume that you define some random variable which take value x1 x2 dot dot xn. Now what is the probability that x take xn plus 1 value xn plus 1? So firstly, what is this? What is the corresponding event for this?
None defined, so it's 5.
5. Then what is the probability of this?
0.
Yeah, which is 0. So same argument is written here. So all the other value of x, probability of x is 0. Okay, other than these xi's, x to xn. Now this is the other property is what? Since x takes values from 1 1 to n. Okay, so as you mentioned that this partition my what, my sample space, right? Right.
Yes, sir.
So what is this? X equal to be x1. What is the union of this? Union of x equal to be xi, I equal to be 1 to n. What is this? This will be what?
Your universal set, the complete sample space.
Complete sample space. And what is
Hmm.
the probability of, and also all these events are disjoint. I already mentioned why this is disjoint. See,
Mhm.
if x equal to be x1 and x equal to be x2. So if x belongs to be this and this also, what is the mean by this? This means x of x equal to be x1 and x of x is x2. But what? Random variable is function, and function can't take two values in single point. Okay, right?
Yeah.
Yeah, that's why these all events, x take value x1 and x take value x2, all these events are disjoint. Okay, so I can use my probability formula. So probability of union ai is what? Sum of probability of ai. You know this formula, all those three axiom of probability, right? If a1 a2 a3 or an are disjoint, then probability of union of ai is summation of ai, probability of ai. You know this property of probability.
So one thing like that you just mapped to the function now.
Yeah,
What function is input, a different input can map to different output.
yeah,
Yeah.
yeah.
But one input cannot be mapped to multiple output.
Yeah,
Uh,
this is the definition of function.
yeah.
Yeah, that's why we call function is well defined or not.
Yeah, it's
Yeah.
well.
Yeah. Okay. So this property also
When we have disjoint thing.
Yeah. So these all are the disjoint things, and these all sum up to what? Union up to S. So what is the probability of union? Probability
Probability of
of
sample
union of
space.
X equal to be Xi is union. Sorry, union is what?
Probability of
1,
sample space, that is
which is
1.
1. And I can write this into what? Summation probability of X equal to be Xi equal to be 1. Okay. Any doubt in this expression?
No, sir.
Yeah. So this property mentioned is here. So these are the three properties and of PMF. Okay. Now let's take an example. Suppose X is the random variable that takes three values 0, 1, 2, 3, 1, 2. Okay. And probability of X0. Where is okay? Where is the question? Okay, question starts from here. So they give some probability of X take value 1 is 1 by 4, X take value 2 is 1 by 2, and X take value 2 is 1 by 4. Then we know what is the PMF. PMF of X equal to be P0 equal to be 1 by 4, P1 equal to be 1 by 2, P2 equal to be 1 by 4. Then this is your tabular form. Okay, these all are now let's check or is this satisfy all the property of PMF. So first property is what? Probability of Xi is greater than 1, greater than equal to be 1. Okay. If you see, yeah, greater than equal to be 0. Probability of Xi is greater than equal to be 0 and less than equal to be 1. Okay, so is this satisfy this condition? Yeah. Okay, first condition is satisfied. Then probability of all other X is 0. Yeah. Okay. And sum of probabilities,
Sir,
sum of
all
PMF.
other X means that any event that is not part of the sample space.
No, any other value that X, X take value 0, 1,
1, 2.
and 2.
Yeah.
Any other value, like if you can you want to find that X equal to be 5, but F is not taking value 5. Okay. So what is the corresponding event for that? 5,
So
because
a doubt here, like if I have some values in my sample space, they are mapped to 0, 1, 2.
yeah,
Uh, does means जो मैपिंग हो रही है सैंपल स्पेस से लेकर इस 0, 1, 2 वैल्यू तक है ना,
हम्म
मीन्स हमने यहाँ पर रेंज को डिफाइन कर दिया अपने इस फंक्शन को जो हमने एक्स को डिफाइन किया।
yeah, our
जब भी हम बात
range
कर
of
पा
X.
रहे हैं या जब भी हम बात कर पा रहे हैं कि कुछ भी है जो इस रेंज से बाहर है वो नहीं होगा।
For that probability is 0, and which I already explained why. See,
या
if X take value, oh, very good. If X take value other than see, if X take value x1, x2, xn, if any value X, what is the event corresponding to this? What is the value of this? Where X is not one of these is what? 5.
या
So what is the probability of that thing happen? 0.
0। हम्म
So that thing, yeah, see. And what is the last property is what? Last property is sum of all pi's. P of xi is what? 1. Okay, if you see this property, this, and why this has happened I already mentioned. Okay, because your all these values, what? All these values, x equal to be xi is partition your sample space into events. Okay, so
Sir,
union of yeah.
sir, does in this case of PMF and this probability functions, we treat this codomain and the range with the same when we're talking about a function?
Which function?
Like this X function,
X function.
yeah, are we treating codomain and the range to be same in these cases?
In which case?
in X we are mapping from sample space values or some values from the sample space to some value 0, 1, 2 and something. Yeah.
Yeah.
So
Yeah.
are we always treating this range is equal to the codomain for this kind of function?
No, no, no. See, assume that I define X is from where? X to R defined by what? X equal to be X1 plus X2.
Okay.
In die case, die is my first, X1 is my first die outcome, and X2 is my second die outcome.
Yeah.
Okay. Then what this value takes? What is the codomain here? Codomain is R.
Codomain is the complete R, but the
Okay.
real
Okay.
values are like 2 to 12. Yeah.
Okay. Okay. What is the range?
2 to 12
2 to 12.
integer value
Yeah.
include.
So
Mhm.
all these values, my P of Xi take some values greater than equal to be 0. Maybe take value 0 and
Mhm.
greater than equal to be 0 and less than 1. Okay.
Mhm. Now
But
also that point is also clear.
now all the other values from other than these from R, it will
Yeah.
take what value? 0.
A 0.
Yeah. Now you are clear.
Yes, sir. Now it's
Yeah.
clear.
Okay. So this all these properties is satisfied by this random variable and PMF. So this is our valid PMF. Okay, because it satisfies all the three properties. Okay, all we have mainly we have two properties or not three. First property is what? P of Xi is greater than equal to be 0 and less than 1. First property is this. And second is what? Summation P of Xi equal to be 1 where I equal to n. Where all possible values of x. Okay, range of x. You can say uh, Xi belongs to be range of x. Okay, any doubt? Okay, let's
No,
move.
sir.
Yeah. So this is the tabular form. Okay. Now we have another thing. So x is the random variable that takes value 1, 2, 3, 4, which of the following property mass function. So this is what? This is our P of 1. This is of P of 2, P of 3, P of 4, and P of 5. Is this valid PMF? It shows no. Why? What is the reason? If you
Sum of
sum this
probability is
also,
greater than 1.
this sum is greater than 1. That's why. Now,
Hmm.
why this is not PMF?
Probability cannot be smaller than 0.
Yeah, because here we have negative probability. And what our first rule is what? P of x is greater than equal to be 0 and less than equal to be 1. Okay.
Hmm.
Now, this is our valid PMF. Is this our valid PMF? Check.
Yes, sir. It's valid. It's 0 to
Yeah.
1 and its sum is 1.
Yeah.
Check.
It's a valid PMF. Yeah. Okay. Now, everyone know what is the PMF. Okay. Any doubt in PMF? Any doubt? What is the PMF?
No, sir.
Yeah. Okay. So now we have one other random variable, which is what? Suppose x is the random variable that take values 0, 1, 2, 3, 4, like infinite. So now you tell me, is this continuous or discrete?
0, 1, 2. It's discrete.
Okay. Any other answer?
Discrete.
Yeah. This is discrete because natural numbers are countable infinite. So natural number are countable. Okay. Now PMF is defined by this. This is our PMF. Probability that x take value I is this. Okay. Now we have to find is this valid PMF. Okay. For some lambda, positive lambda I. For what value of this C? This is the valid PMF. So how to find? So you find this by how? Summation C lambda I upon I factorial I is equal 0 to infinity is what? 1. Okay. Now find value of I C for that. So everyone know what is this I factorial. I factorial. What is this? This is the expression of
E.
exponential. Okay. Now see, they
Mm.
use this. Now if you see this condition, after that we have this condition, and after that this is the expansion of e to the power x, then e to the power lambda, this is the e to the power lambda. So this sum is c e to the power lambda. Okay, any confusion in this calculation till now?
P
So
summation of px.
so these type of question are in your, I think, your problem sheet. So if any you have any doubt, you can ask. All this calculation, any doubt in this calculation? Okay, so now for second condition for 2, we have this condition. Now which value of c this is true? C equal to be e to the power minus lambda, because e goes to in denominator. Now this condition is okay. Okay, this is the answer. Now we have rolling or die case. So these are the total outcome 36, and x is the random error which define the
So,
sum of the
like,
out.
sir
Yeah.
Akbari, like, just scroll a bit up, please. This function, yeah. In this function, it's just one of the candidates for how this PMF can be, yeah.
What?
ये खाली एक एग्जांपल है कि हमारा पीएमएफ फंक्शन किस तरह का हो सकता है.
No. This is the, see, x is the random variable which takes value this, and PMF is defined by this. Then is this valid PMF? And how, which value of C this is the valid PMF? Okay.
Oh, and just a second. It's I. This I value is X.
Yeah, this I value is x.
Okay.
Yeah.
Got it.
So x is the sum of the, then you know what is the probability PMF, how to find PMF. X will take value 2, 3, 4, 5, 6 like this. Okay. So verify that this is valid PMF which you find. Okay. Which is valid because by construction we know, but you have to check. Okay. How to check? Just sum all these things you got. Okay. Now we have concept of what? CDF. So what is the CDF? CDF is what is the probability that x will take value less than x or xi. If I say that x, find if f is the cumulative distribution function, assume, okay, f is the cumulative CDF, then what is the value of f of 7? F of 7 is what? Probability of x, probability of x take value less than 7. Okay, less than 7. What is the probability that x will take value 7 plus what is the probability that x will take value 6, 5, 4, 3, 2? Okay, now we will see, okay, in next example. So this is the PDF thing we already see this, what is the PDF. Now this is the PDF. Okay, now we will see. Okay, for firstly we have we discussed what is the graph, how to find graph. Okay, let's see what is the graph. So this is a PDF thing we already discussed. So it is helpful to illustrate the probability mass function in the graphical format to plot on x-axis again the okay y-axis. We will see what. Okay, now x takes values what? 0, 1, and 2. And what is the probability that p of okay, let's now x take value 0, 1, and 2. Okay, and we know what is p of x. P of x in this case 1 by 4, 1 by 2, and 1 by 4. So we want to graph this. So we define our x where. So this is the function. So where is the outcome? Where is the input? Input variable are here. Where is the output value? Output is here, which is p of x. Now when my input is 0, then what is the outcome? Which is 1 by 4. If my input is 1, so this is my first point. Then my input is what? 1 by 2, which is 1 by 2. And when this value is 2, then okay, this is the graph. You know how to draw graph of function. So PMF is your function. So I think you know how to draw graph of function. So same thing is happening here. So this is the graph of your PMF. Okay, any doubt? Similarly, this is graph of your another PMF. Okay, this is the graph of another. How to draw this PMF? This is the another PMF. Like this, you have graph. Okay, for different PMF, you have different graphs. This is equally likely case. This is the die case. Okay, and this is the case of two dice. We are sum of dice, sum of x's. Okay, what is the sum of outcome? So this is the graph, and which is true. Why? So how many values have sum 2? Only 1. How many values have sum 12? 6 only. Similarly, how many values have sum 11? 6, 5, 6 and 6, 5. Okay, and similarly here, how many values have sum 3? 1, 2 and 2, 3. Only 2. So that's why this is symmetric about 7, right? Okay.
Yes, sir.
Yeah. Yeah. Now we have, this is the same thing. How to draw? I think all you know. Now we have last thing, cumulative distribution function. Okay. So what is the cumulative distribution function? So this is the definition, right? I already mentioned this definition. Probability that x take value less than a, less than equal to be a. Now we will see some examples. So x is the discrete random variable. So since till now we only studied that discrete case. So we will define on PMF that CDF only for discrete, but CDF also defined for continuous case. But for that, we will I think in week 10 there will be the CDF for continuous case. For that, firstly we need PDF, probability density function, which is defined for, which is the analog of PMF in continuous case. Okay. Now let's see how to define cumulative distribution function in this example. So this is my x which take value 1, 2, 3, 4, and this is what? PMF, right? Okay. So this is the PMF, if you don't know. Now, what is the cumulative distribution function for this? So firstly we draw the graph. Okay. Of what? We draw graph of what? We draw graph of PMF. So this is P of x, this is x. Now what value it will take? 1 by 4, 1 by 2, 1 by 8, 1 by 8. Okay. So 0, 1, 2, 3, 4, 1 by 4, 1 by 2, 1 by 8, 8, 1 by 8. Okay, sorry, which value? Okay, 1, 2, 3. So assume that this is 1, 2, 3, 4. Okay. So here is the 0. Okay. Now, what is the probability that, now we want to define what? Our cumulative distribution function. which is what? Probability of x take value less than x, small x. Okay. Now, how to define this? Now, if x is less than 1, if x is less than 1, yes, x is less than 1, then what is this? This means x take value less than x, means 0, -1, -2. But x take only 1, 2, 3, 4, these values. So this is 5. Okay. So what is the probability of this? 0.
0.
Okay.
Hmm.
So this is 0 for x less than 1. Okay. And till greater than -infinity. Okay. Now, what is the value when x is 1 and less than 2? Means, okay, yeah, x is less than 2. Okay, what is the value when x is less than 2? This means what? Probability of this means what? X is less than 2. Okay.
That is x is
Sorry.
equal to 1.
This means what? X take value what?
1.
X can take value. Assume that this is greater than equal to 1. Okay. X is greater than equal to 1 also. This means what? X take value 1, 0, -1, like this. But we know x of xi, so xi less than equal to be 0, less than equal to be 0 is what? 0. Probability of this is, we know. Okay. So this is what? Probability of x1 union x equal to be 0, union like this. But all these are 0. This is what? 1 by 4. If you see the diagram, 1 by 4. Okay. So this will take value 1 by 4 when x is greater than 1, equal 1 and less than 2. Now, what is the probability that when x is greater than equal to be 2, less than 3? In this case, x will take how many values? X can take 1 or 2. Okay. For that, what is the probability for 1? For probability 1, we have 1 by 4. And for probability x equal to be 2, we have 1 by 2. So this is what?
No,
1
you
by
have
4.
restricted x to be between 2 and 3. So
Yeah.
should not we avoid the value of x equals to 1 also?
No, no. Why? No, no. I
You have
am
defined this x as between 2 and 3.
x is
So,
small x is between 2 and 3, not x. Capital X is less than that value. Assume that I take x is 2.5. Okay. This
hmm.
means what? X less than 2.5. This means what? X take value what? 2, and 1 is also less than that capital X.
But is not it same as saying x small
Okay.
x is less than equal to 3?
No, no, no. Assume that. Yeah, less than equal to be not equal to 3. Because if I use equal to 3, then x can take value 3. And this
Okay.
x, okay, I note this by a. Okay. So that you can't. This is a. This is also a. And this is also a. Then what is the probability that capital X take value less than a? This. Okay. Here. So what is the, if x a belongs to where? 2 to 3, not include 3. Okay. Then what is this? This means what? X can take value what? 1, 2, 3, 4. But if x is less than 3, a is less than 3, then x can take means x, in this case x can be what? 1, 2. Okay. Because a is less than 3, I'm not including 3. Okay. Any doubt?
No, sir, got it now.
Yeah. Similarly, you can find this value also. So we will see what is the value in here. Now see, if x a is less than 1, this means x is less than what? A. This means what? Probability of x less than a, and a is less than 1. This means x takes value 0, -1, -2, -3. For that values, probability is what? 0. Okay. Now similarly in this case, if x take value, a is taking value from 1 to 2, not including 2. This means what? X can take, this means if I writing x less than equal to be a, then x can take values like 1, -0, -1, -2. But all other than x equal to be a, all are 5. So in that case, I will get this. Similarly, if I use this, then x can take value this and this, right? So what is the sum of this? Exactly this. Divide by 2 and 2, then this is 2 by 4, this is 1 by 4, this is 3 by 4. Okay. Similarly, what is the value x take value for this? So x in this case, x can take which value? X can take 1, 2, 3, but not 4. Okay. So 1, 2, 3, sum these all these three values. This is 7 by 8. Okay. Similarly, what is the probability that x can take value less than equal to means if a is greater than equal to 4, means x can take value what? 1, 2, 3, 4, all possible value. Then what is the probability? By property, this is the one always. Okay. And this is the graph of cumulative distribution function. How? See, now if you see x is f of x is also function. What is the input? Input is x, so input is always in x axis, output is always in y axis. Okay. Then x can take value 1, 2, 3 and 4. Now if value of x is less than 1, what is the probability? What is the f of x? Is 0. Okay. So this is 0. Now what happen when my x is 1? When x equal to be 1, small x is 1, this means what? F of 1 is what? Probability of x taking value less than equal to be 1. This means what? Probability of x equal to be 1. All other probability are 0, which is what? 1 by 8, I think. No, 1 by 4. Okay. So till 2, this probability is continue. After that, at 2, what we have? We got another probability, which is what? Which is this 3 by 4. So this is 3 by 4. Till 3, this is continue. After that, at 3, I will get which value? 7 by 8. So this is 7 by 8.
So is not it like probability till 1 up to 1 is 0, then it's
Yeah.
from to 2 is this. Yeah, okay.
Yeah.
Okay.
Yeah. After that, this is continue at 4, and after that, after 4, I have what? Continue with 1. 1. Okay. Okay. Any doubt in this question? So what is this? These are the jump. This called jump. And what is this? This value? This is exactly probability of x take value 1. And what is this? This is probability of x take value 2. This is probability of x take value 3, like this. Okay. Now how this is possible, we will see. So this is the graph. Okay. Okay, this thing you will I think this is the for next week, why this is this. Okay. Till now, everything clear? We already see what is the yeah.
It's clear now.
Yeah. Okay. Okay, I will also show why this is this jump are probability of x size. So what f is what? F of x, f of okay, f of 2 is what? Probability of x take value less than equal to be 2. Okay, what is f2 minus? Means that value is just less than 2, not 2. For that, what probability of x less than value minus 2, 2 minus, sorry, which is what probability of x taking value less than equal to be 1. Okay, because between 1 and 2 there is no event. Okay, x take no value between 1 and 2, 1 and 2 minus. Okay, so this is this. Now if I subtract these two, f of 2 minus f of 2 minus f of 2 minus is what probability of x less than equal to be 2 minus probability of x less than equal to be 1. Okay, so this is what this gives. Here we have what probability of
Sir,
x equal to be 2.
this f of 2 should not it be probability of x less than equal to 3,
What?
less than 3.
Which
F of 2 is
Hmm.
should be probability of x less than 3.
Yeah, you can also interpret it as this is as this and this thing are same na, probability of x less than 3, because
Hmm.
x see between 2 and 3 the x not taking any value.
Hmm.
This means what I can directly go to the x equal to be 2.
Yeah.
Yeah, so these two are same thing,
Hmm.
which I use here. Where here.
Yeah, in f of 2 minus we used.
uh,
Yeah.
yeah. The f of 2 minus see x less than 2 minus it means x less than 2. Okay, these two things are same. Okay.
Hmm.
But in continuous case these two things are not same. Okay, but
Okay.
we are in discrete, so we can say now
Okay.
this is what probability of x equal to be 2 and probability of x equal to be 1, and for x equal to be 0 all other things are 0, minus probability of x equal to be 1 and all other things are 0. If I subtract this, then I which I get what I get this, which is exactly the this thing.
Hmm.
Probability of this is my what then, sorry, this is my what f of 2,
f
and
of
this is what
f
f
of 2
of
minus.
2 minus. If I subtract this I will get this, which
Hmm.
is probability of 2. Okay,
Yes.
yeah, any doubt in this? Now I think you can solve your deadline, because it is easy. There is no calculation or other things. You have to be just find probabilities, which you already know from week 8. Okay,
Hmm.
any doubt?
Sir, I actually had a doubt regarding one of the practice assignments.
Okay,
So what
which week?
happened? Oh, that will be like, not about a question. So what happened is the grades just came out for practice assignments. And
Okay,
then I see that on week 6, one EMQ, right? The
okay,
grade is not given correctly. When I go into the EMQ, it shows me 100 out of 100, but the grade is showing as 14 for some reason.
okay.
So what to do about it?
Okay. This issue for in only in your grade sheet, or any other, anyone else have this?
Yes, sir. A lot of people are having issues that they are being shown absent in the grade assignments, but I did not have that issue. I just had
Okay,
this issue because is it okay if I share my screen?
okay, yeah, but I think there is only permission for host and co-host, so
Okay,
I think
maybe
you
I'll
can't
just
share.
send a screenshot.
Yeah, but instead of sending me, you can send to technical team, because I don't know all these things, na,
Oh, okay,
and
okay,
it is not in my hand.
right. Oh, okay, okay. So I'll just contact that support at the rate IITM, that one, right?
Yeah, yeah.
Okay, okay, okay. I'll do that. Okay, sir.
Or if there is when will the Prashant sir session, and
Uh,
any senior educator?
Sir, like it's same for me. Like I have submitted the EMQs for the week 8,
Yeah.
but it's showing not submitted.
So you have to be right for mail for the technical team support,
hmm. Okay, sir.
because
Okay, sir.
all these things, because see if you send me, then I discuss this in meeting, but they will also send this thing into technical team. So instead of sending me, you directly send technical team.
Yes, I'll do that. And
Yeah.
also, by the way, do you know in which session we can talk with any of the any of the TAs, actually, the people who are in charge of grading? Is there anyone like that in these sessions?
Uh, no, there is no. I think. See, there are some senior educators who like Prasant sir and Srikant sir.
Mm-hmm.
You can ask to them, but I think all TA are new and I am also new.
Oh, okay, okay.
So
So
yeah,
it would be better to just contact the support team. Okay.
yeah,
That.
yeah.
Okay, sir. Okay. Thank you. And also, I had one last question about that bonus. Is it it says average, right? So let's say in the first practice assignment, I get 100%, and then the next one has 50, then next one has 80. So do they take like the average? The first one is 100%, then the next one is 60%, 70%, and then average it out? Or do they like add all the marks and then divide by number of assignments?
Okay. Add all the marks and divided by.
Like a number of
So
assignments.
is there any bonus question also?
Yeah, there are bonus for submitting the practice assignments, right?
Okay,
The 5 mark bonus.
okay.
Asking how is it calculated?
So, see, like if if you got 100 in all the subject,
Hmm.
then these marks count in up to after 105 and like this.
Yeah, so what happened is I missed one of the mocks. So
Okay,
basically I missed one of the mocks. So all I'm asking is let's say the in the practice assignment I got 100 in all the practice assignments. And
okay,
then since one of my mock is let's say 0, right? The rest
okay,
of them are all 100. So will
okay.
it be like 100 plus 0 and then divide by number of assignments, right? Like
So
it'll
where
take,
is the bonus mark?
yeah, for the bonus mark to see if it is greater than 40 or not. Because 40 is the minimum they said.
But bonus marks in your assignment, no?
Oh no, they said that they'll give 5 mark bonus on top of the 5 marks added bonus with the final score. We got an email about it.
So in which sense, in which they provide bonus in question or in attendance or in assignment submission?
Oh, that will be
Sir, for assignment submission.
hmm.
Okay, then I think in last you will if you submit all your assignment, then you will get bonus question marks. I think.
Okay. So basically it will average out to see the minimum criteria, right?
Yeah,
Okay,
maybe
okay.
they have some criteria. I don't know about.
So where do you think I can contact about this to get full information regarding it?
Support team.
I contacted the support team all about this already. They told me that the support does not deal with very technical answers about subjects. They told me to contact the educators, but I don't know who the educator is.
Okay, okay. I will ask to educators, my senior educators, so that um, they will discuss this in next meeting. Okay.
Okay, sir. Okay, thank you.
Yeah. Yeah.
So I have one question.
About what?
It's like to from the quiz too that we just
Okay.
in that we had one question. A family has two childrens.
Okay.
Assuming a male or a female of a child is being equally likely.
Okay.
So what kind of sample space would it be?
So what's the question? A couple
A,
have
a family has two childrens. Uh,
okay.
being a male or a female of a child is equally likely.
Okay.
I wanted to see what kind of sample space it would look like.
And how many children they have? They didn't mention.
No, sir.
Okay.
I
Yes,
think what he's trying to
yes,
say is
a family has two children, nothing more than that.
Okay. So they they mentioned they have two children. So your
Yeah.
sample space is like mm, girl, boy, boy, boy,
the permutations.
boy,
Yeah.
girl, and girl, girl. Depends on your yeah. This.
So just one doubt here. Like I did, what I considered is
And what
uh,
is the further question after that?
I
A family
find out
have
that
to.
at least one child is a boy, and so
Explain
This
please.
question had two sub questions.
Yeah, they said
Okay.
if at least one child is a boy, then what is the
Okay.
probability that the other one will also be a boy?
Okay. Yeah. So your sample is space is this. Okay. Yeah.
Sir,
Yeah.
like one question here, like what I consider is when I'm asking that how many kids do you have in your family? Okay,
Okay. Okay.
your answer is going to be one boy and one girl.
Yeah.
You're not going to say me that
Yeah.
uh
Yeah.
you have an older sister or a younger boy.
But I think if you, as you mentioned, the further question that what is the probability that what
At least
further
one
question?
child is a boy.
Okay.
It
And
also
second
doesn't.
part is
Second, first part is first question. First sub question is
hmm,
find the probability that at least one child is a boy.
okay.
It also does not signify that I have to consider some order.
No, find the probability that one.
Find the probability that at least one child is a boy.
Okay. And second part is what?
Second sub question is what is the probability that both are boys given that
Okay.
at least one is a boy? This
Okay.
question also does not signify that we have to consider a
Okay.
sub.
Now assume that. Okay. How to find sir, how you find this that both are boys given that at least one is boy.
We'll just
That,
take
that's easy. If I
One
consider what my
is
sample space is going to be, I just have to
one.
take as a part of that sample space and I am done with it. But my question
So
here is
what is
on
your sample part? What is your sample that sample part?
there'll be three options, right? So at least one boy is going to be boy boy, then boy girl, and girl boy. So three.
So no, I know asked you the guy how to find you this.
So there'll be, sir, only
what
one of
sir,
those three options. So one third.
One
So
second, one second. But I don't
one
know your name, but I want to know this question from that guy who asked this question.
sir, the initial sample space that I draw is
Yeah,
just
what is the
one
sample space?
one girl, both are girls,
Okay,
boy boy,
boy.
and girl boy or boy girl. That's an equivalent.
So
I
you write like this. Okay,
Yeah, I read that.
yeah,
Yes,
yeah.
this is possible,
Now
sir.
what is the probability that this happen?
It's one by third,
Okay,
both are
what is
girls.
the probability that this happen?
One by third,
What is the probability that this happen?
one by third.
Is this weird for you or is this correct for you?
So it's sum of probability is
But
one.
But you know that this event can be happen in two types, either boy girl or girl boy,
So
right?
I thought of this question in a practical sense that if I am going to ask someone that how
Okay,
many children do you have in your family,
okay.
he or she is going to answer
But
me on this
that
two.
probability of that couple have probability of that couple have boy and girl is higher than probability of that couple have boy or girl.
So
Is this reasonable?
that is a question when we have decided on the sample space. But if
So,
we practically see
but
that,
you are finding that probability of that this BB happen. You are finding this now. So for that, you have to be find all the other things. Consider all the other things. So what you in general what happen if the probability of BB happen if boy happen is P and assume that uh, happening of boy is 1/2, happening of girl is 1/2. Okay.
hmm,
Okay. Then what is the probability that this
if it's I'm talking about the sample set that you have drawn, it's 1/4. But if I'm going with the sample space
one
that
by two?
then it's 1/3.
Why 1/3?
So
See, it's B for BB for BG. I have what 1/2 into 1/2 for GB. I have what 1/2 into 1/2. Add that this thing. I get what 2/4, which is 1/2. Similarly for BB happen what? BB happen in 1 by 4 and GG happen is 1 by 4, right?
So it's going a bit ahead for me. Just let me just please tell me how I'm going to tune this thing to rest of the questions. My
Okay.
query is just simple, that if I'm going to ask some person who
Mhm.
is sitting with me that how many children do you have in your family, he is
Okay.
going to give me a short and precise answer. Two
Yeah,
children.
two children.
And how many of them are boys or how many of them girls? He is going to say
Yeah.
only one boy or one girl, only or only
Okay.
two boys or
So
one girl or one boy. Only three
so
these three options he is going to say, not the four.
yeah, he will see. But is the probability that one boy and one girl happen, is this probability is higher than both are girl or both are boy? Is this reason? This is correct now? That's the logic apply in here. That's why if you are assuming that your sample space is this and all are equally likely, okay,
Hmm.
but all are not equally likely. This is more likely than this. Maybe
Hmm.
let's see what they consider and what. But for me, this is the correct.
So they have considered that because, but I consider this point from in the exam that I don't consider the order because of this simple logic.
So if you don't not consider other, but you have to be give more probability to this, that BG.
Hmm. But that's only going to be when we are considering going to consider the order.
Yeah, yeah.
So it should not as a hint should have been laid, like saying then elder or a smaller or something, elder or younger thing. Then this order thing would not have raised. But in a practical sense, when I'm going to ask that for just two childrens, I'm
Mm.
certainly not expected to get an answer, an more elaborated answer that it's being a younger is this and uh, elder is this. I'm certainly not
but
expected to get an answer like that.
like no, no, but in this type of question you have to be know if you are giving equally likely probability, then is this equally likely or not?
So that is based on the context in which we are considering. No?
Yeah, so but based on concept, this is not equally likely. You are saying that these all are 1 by 3, 1 by 3, 1 by 3, but this is not possible.
Hmm.
Yeah. So question never gave you that this is equally likely or not.
Hmm.
If you are saying that these are equally likely, then make it equally likely. Okay. By considering this, you can say that these all are equally likely. Okay.
Hmm.
Yeah.
So if I am going to now I am going to extend the same question to rest of the questions. Like
Yeah.
when I'm drawing the one black ball, at least one black and one red ball. Okay. Now I am forced to consider the order also. That it's first going to be red or secondly it's going to be red. That
Hmm.
in that case the answer will go off tracks
No,
of
no.
the
In
calculator.
ball case, what happened? See, in ball case, first ball is black and second ball. In that case, you are giving some equal probability to all these cases. Now, if you know the probability of that one ball is black and one ball is red, and other that both are red and both are black, if this probability you know, okay,
Hmm.
no need to do this ordering. Okay, how to find this? One black ball and one red ball. You choose total number of ways how to choose one. Assume that you have 8 black ball and 7 red ball. So how to find this? You choose 8C1 7C1 divided by what? Total number of balls, which is 15C2. This give you what? Probability of BR. In
Hmm.
this case, this will be happen like this.
Yeah, but now
Yeah,
consider this. When I'm asking you that
yeah,
one ball has to be blue and one ball has to be red, but
yeah,
you are considering only one case when it is
yeah,
first blue and the second red. You're not
yeah.
considering the case when the first is red and second is
Now,
blue.
now same logic apply here in
So
case of
it's
G
applying.
G.
It's
Yeah.
it's
So
applying.
answer.
That's why when
So
I'm
if your
saying
answer is same,
the
so
which
you
one?
have assume that you have one black ball and one green ball. Okay.
No,
Now
no.
what is the
Sir.
yeah,
I'm going to continue your same question. You
yeah,
said you consider a pair, an ordered pair, that first is blue, second is red.
yeah,
But the question is given that what is the probability that one is red and one is blue? Then it is
hmm,
if you're considering the order, then first is blue, second is red. Then you are also bound to consider the order first is red and second is blue.
yeah.
So, but you have only given me one half, like a half probability of that. What's it's going to be happen. So that's also considered wrong now. I will
Huh?
have to multiply it with 2 to consider the order, 2 factorial.
But probably you are saying that if you have order, but by just divided by two, you can get unordered probability.
Yeah, now but you have considered the order when you are considering
No, no,
BR.
no. By dividing by two, you can't get unordered probability
So
because
by dividing by 2 factor I can, because
by
it's
divided by two, you can find the number of ways. See, if I divide by two here and two here,
no sir, but just
no,
one
no,
two,
sir. What
just one
what
two.
is no, no. Firstly, I have to find the probability that order probability. Okay. First is red and second is red. How many
So
ways I can?
you have considered order, na? It's 8C
No,
one
no.
time.
This is not ordered. This is not ordered. I just combine. This is a not. This is combination, not permutation.
So just consider the numerator thing. You have to
Yeah, yeah.
put.
This is also a combination, not permutation.
Sir,
I
individually
can
they
write is
are.
7C1 and 8C1 are and 8C1 and 7C1 are both are same. This is also a combination, not a permutation. I'm like saying like this that first ball is black and second ball is red, but this is not permutation. This is combination.
So a bit, I will require a bit
See,
more elaboration on this point.
okay.
What I consider in this question till now is like जब मैं इस तरह का कुछ भी बना रहा हूँ मैंने दो ब्लैंक्स बनाए ठीक है
Hmm,
फर्स्ट में अगर ब्लैक बॉल कर रहा हूँ सेकंड में मैं रेड बॉल कर रहा हूँ तो फर्स्ट
hmm,
में मैं देख रहा हूँ भाई ब्लैक बॉल में कितना काउंट आएगा ठीक है
8C1
तो या 8C1 आया ठीक है
and
अब
7C1.
काउंट
Now
जाओ
this is not a order. This is a red ball. This is black ball. Okay, this is black ball. This is red ball. Now how to find permutation of this? By divide into two, because R and B can also possible, na? Right? So
Hmm.
this is combination. You are just picking two balls from different urns.
So if I can just submit, like I was considering it to be an order. सब कॉम्बिनेशन का मतलब तो कलेक्टिव उठाना होता है ना व्हेन आई एम डूइंग
हाँ
अ
तो वही
मल्टीप्लिकेशन
तो कर रहे हैं ना.
लेकिन सर हम
You have to
मल्टीप्लिकेशन
earn.
कंसीडर कर रहे हैं मल्टीप्लाई
Assume that just second, just second. You have to earn in which red ball are numbered from 1 to 7 and blue ball are numbered from 1 to 8. Assume
या
that you have two earned. Okay.
या
Now, how many uh, how many ways you can find uh, collect one red ball and one black ball? How many ways? For one ball, for one black ball, B1, you can get how many red ball? R7, 1, R2, R7. Similarly, for B2, you can get what? R1, R2, R7. So how
या
many ways I have? 8C1 into 7C1.
या
Yeah, this is not permutation. This is combination.
हम्म
Yeah, don't confuse between permutation. I am
या
using multiplication use. This is not mean that this is permutation. Okay.
हम्म
Yeah. Okay. Now
okay
it's 9. I have to be go to the for dinner. Okay.
या ओके
Okay.
थैंक फॉर द सेशन सर
Yeah. Okay. If you have any doubt, then ask in next session. Okay.
Okay, so that was the only question that I make a mistake, but
Okay.
ah,
Yeah, for that you have to firstly make your probability to equally likely for that using that, and your the way you describe your sample space in that your outcome are not equally likely. Okay.
yeah, that's one. But is it like for if is it possible to frame a question that favors that particular condition?
Yeah, you can frame question, but you have to be assign probability different if your outcome if your that event is not equally likely, that outcome
Oh.
is not equally likely, then firstly define the probability for that event, then
Mm.
outcome, then you can use that argument.
Means in that particular case, if I'm going to consider, then the probably having a boy or a girl child is not going to be equally likely. They are going to be
Yeah,
associated with some probability there.
yeah, firstly if you are not using equally likely probability, then firstly define your probability for each outcome,
Okay.
because you what you are doing, doing simply that how favorable number of event divided by total number of event outcome, okay, sorry, total favorable number of outcome divided by total number of outcome, and
Mm.
when this formula is used, when each outcome is equally likely,
Mm-hmm.
you know this one, n upon m upon n, when this will be used, when each outcome is equally likely, then you can use this formula, but
Mm.
your each outcome is not equally likely.
Mm.
Yeah, that's all.
Okay. Thank you
Okay.
for the session, sir.
Yeah.